Today we're going to take a look at how to find the determinant of a matrix. Every square matrix, a square matrix is one that has the same number of rows and columns, like a 2 by 2 or a 3 by 3, has a determinant. And determinants are used in other things. This course is only going to take it to how to find it. Later courses you'll learn how to use it. It's used in finding the inverse and things like that. But we're just going to concentrate on just finding it. There are two different ways for them to ask you to find the determinant. This is probably less common with the DET. It kind of gives it away. You notice that there are square brackets when they use the DET for determinant. This is the more common way. So you're going to see in assessments something like this, and they're going to ask you to evaluate that. And so you have to know that the straight bars, they kind of look like absolute value bars, but it's around a matrix, means to find the determinant. So in this case, to find the determinant, you basically are going to take AD, so this diagonal, multiply it, and subtract off that diagonal. And it's going to give you a number or a value. So let's look at this example here. We need to find the determinant, and so AD would be these positions. So we'd have 4 times 9 minus BC would be these two positions. Negative 4 times 8 is going to give us 36 plus 32. 36 and 32 would give us 68. So the value of that determinant is 68. Now 2 by 2s are pretty straightforward and easy. However, a 3 by 3 is going to be a little bit more involved. A 2 by 2 is called a second degree determinant, and a 3 by 3 then would be called a third degree determinant. So we're going to take a look at this type of determinant. It says determinants of 3 by 3 matrices are called third order determinants. And so we are going to do that with this particular problem here. So go ahead and jot that down. Our problem. Using the diagonal method. And I'm going to show you the rules, whether it's easier for you to see it visually or it's easier for you to see a list of rules. So I do like the book, and our personal textbook, the green one, Glencoe book. It's on page 221. Here's a list, and we're going to work this problem out, and this is actually the problem. But here's our steps of rules. It says to rewrite the first two columns to the right of the determinant. So if you look at this example, here was the example that we just wrote down. We basically are going to take these first two columns, and we're going to write them on the other side. So let's do that. So actually, I wrote that there, so I'm going to need to rewrite it here. I've got 4, negative 3, negative 4, 8, 2, 5, 3, 6, 9. So I have my determinant bar, and it said to take the first two columns and rewrite it. So 4, negative 3, negative 4, and then negative 8, 2, and 5. So we've done what it's asked. So step 2 says, draw diagonals beginning with the upper left-hand element. Multiply the elements in each diagonal. Repeat the process beginning with the upper right. So let's look at their little picture here, and we'll do this as well. So they're going from left to right, going down, and they drew 3 diagonals because those are the only 3 that have all 3 numbers. So let's do that. So I'm going to use a little highlighter. So you might get yourself a little colored pencil there. So I have 4, 2, 9. I have negative 8, 6, negative 4. And I have 3, negative 3, 5. And then it said to multiply the elements in each diagonal. So we're going to take, for our pink, we have 4 times 2 times 9. Well, 4 times 2 times 9 is 72. And then our next diagonal, we have negative 8 times 6 times negative 4. And that gives us a total of 192. And then we have 3, negative 3, 5. And that's going to give us a total of negative 45. So these are our pink ones. These are our pink diagonals. Now, if you're looking at that example in the book, now they're going to do diagonals going the other direction. So we look for where we have 3 numbers in a row. We've got negative 4, 2, 3, 5, 6, 4, 9, negative 3, negative 8. So now let's go ahead and do that over here. So we have negative 4 times 2 times 3. That gives us negative 24. We have 5 times 6 times 4. Those are just coming right from there. 120. We have 9 times negative 3 times negative 8. And that's 216. And that just came from each of those. So those are our yellow diagonals. So then, step 3, if you take a look, if you're looking at your book, step 3 says find the sum of the products of the elements in each set of diagonals. So, the sum for this particular group is 72 plus 192 plus negative 45. And that gives us 219. And then over here we got negative 24 plus 120 plus 216. That gives us 312. So again, there's our yellow, there's our pink. And the last step says to subtract the second sum from the first. So the second sum from the first. So we have our 219 minus 312. And so the determinant would equal negative 93. A little bit more labor intensive, but it's not difficult. We just have to remember we got to write the first 2 columns over and draw all going from left to right in the diagonals that you can do going down, and then you go from left to right again, but starting in the lower corner, and you go up. You multiply them together, find a total, and then take the totals and subtract them. So that's how you find a determinant by hand. You can use a graphic calculator, and you have instructions for that. However, there are some that you just have to do by